Okay, so in this video, I'm going to give you a brief explanation about net energy metering calculation based on SEDA's NEM calculator. Okay, so first reminder, I want you to ignore the old slides on net energy metering available in the past lecture notes. Because that one at that time the calculation was slightly different, and I'm afraid it might contradict the information I want to share today. Okay, so first of all, before I proceed, I would like to take you back into this slide here. This is taken from a GCPV system design. Hold on, I think this one is from system performance. GCPV system design part 2. Okay, so slide number 12, it mentioned that the energy yield or the energy output is equal to the rated power times irradiation times losses. Okay, here I made a small mistake. It's actually not losses. So in the slide, it mentioned losses. I want you to correct it to performance ratio. Okay, so the correct term is performance ratio or PR, not losses. Okay, so now let's say this is an example of electricity bill from a TNB customer, and we have some information. Let's assume that this is actually a house owner. We are not sure about the details, but let's just assume it's a simple house owner, maybe a terrace house, rumah terrace. Okay, anyway, the total energy consumption per month for this owner or for this customer is 850 kilowatt hour. So TNB charges the rate based on block. The first 200 kilowatt hour is going to charge 21.8 cents per kilowatt hour. And then the next 100, 33.4 cents, and so on, so on. The more you use, the more you pay. That's the principle of TNB charging. Okay, so now the total energy consumption is 850 kilowatt hour. So the total bill before the taxes, before late surcharges, before KWTBB charges, which is service tax is 6%, KWTBB is 1.6%, and late charges, that depends. Late charges depend on how late you pay. Okay, we don't calculate that one first. We just calculate the amount of energy used. So we take this value here. Now, let's go to SEDA's net energy metering website. So if you go to SEDA portal, seda.gov.my, RE portal, NEM, you'll find there's an option for NEM Calculator. So when we click NEM Calculator, we'll be taken into this window. Okay, so let's take back the bill just now. So let's assume it's a domestic tariff because it's obviously from a house. And there are several types of houses listed here. Let's take terrace house. And we enter the value just now, the average electricity monthly bill before the surcharges and the taxes, RM363.80. So let's calculate. Okay, so we are brought to this next window where we have all the calculated values here. Now, the proposed install capacity is given as 5.42 kilowatt peak for this condition. But let's say I just want to increase it. So here it is adjustable. We can adjust according to what we want the capacity to be. So let's say I fix it at 6 kilowatt. So the install capacity, I want it to be 6 kilowatt. So these are the details that is given. So if you install, then the total upfront cost will be 25,800 for 6 kilowatt. and your bill will be reduced from 363 ringgit 80 cents into only 58 ringgit per month, if you assume the monthly bill is this amount. Okay, so this translates into 306 ringgit of savings. All right, so now we want to make sense of these values according to calculation estimation. So let's go back to the slide. Okay, so the SEDA calculator made several assumptions. So assumption number one, for 1 kilowatt peak of installation capacity, 1 kilowatt peak of capacity, it requires 6 square meters of effective rooftop area. So in other words, if you want to install 1 kilowatt of PV system, you need 6 meters squared of area. All right. And the minimum upfront cost is based on the following values. So up to 10 kilowatts capacity, the charge will be 4,300 per kilowatt. This includes the charge for the module, for the inverter, for the cables, protective device, and so on. Now, as we go higher, as the capacity goes higher, then the price starts to drop. So if you are installing for let's say for a factory that has a large rooftop area, and you install up to 200 kilowatt above, then you can expect the price of system per kilowatt is going to be reduced dramatically. So in this case, SEDA assume 3,000 per kilowatt. So you must note that for SEDA, the calculation is done based on minimum upfront cost only. So actually, if you try to get quotations from PV installers, the price will vary and might be more expensive than the value quoted in the SEDA calculator website. So prices vary because of several factors. First of all, because of market value. Even though in general PV modules drop the price every year, but not necessarily the case. It also depends on the PV technology that you use. Like if you use monocrystalline and polycrystalline and thin film, they have a different price range. And also depend on the manufacturer of the module that you purchase. So tier 1 or tier 2 modules will have more expensive prices. Okay, and it also depends on site condition. So if the site condition requires some extra work, for example, you need to install specialized structure to support your PV module, or you need to consider like special equipment to set up your solar PV system, then that might be additional cost. Okay, so a lot of factors, but this just wants to provide you with a rough overview. Okay, moving on. So let's say we have this value just now. So we want to install a capacity of 6 kilowatt, and these are the rough estimation that is obtained. So how do we calculate this value? Okay, so this is the equation that I corrected just now. So if you want to calculate the energy from PV, it is PV capacity, the total installed capacity, multiply with the estimated peak sun hour, multiply with the performance ratio. Okay, so for the estimated peak sun hour, we are going to assume 4.2 hours per day, roughly, or 126 hours per month. So we want to convert it into monthly values. So these are very rough estimation, and we must remember that peak sun hour is dependent on location. For locations located in the northern part of the country, like Perlis, Penang, Kedah, the amount of daily sunshine is much higher compared to locations such as in Malacca or Johor. Okay, but for simplicity, we assume the value is set to 4.2 hours per day or 126 hours per month. And we assume that the performance ratio is 80%. in other words, the total overall losses is 20%. So when we talk about total overall losses, this includes losses from heat or temperature factor, irradiance, cable losses, inverter efficiency losses, and other types of derating factors. So we just sum up as 20% losses or 80% performance ratio. Okay. So now we calculate energy from PV. The capacity that I want to install just now is 6 kilowatt. The PSH per month is 126 hours and the performance ratio is 0.8. So I get roughly 605 kilowatt hour from my PV system. Now recall that the consumption was 850. Okay, 850. Okay, so now 605. So the net energy that we are actually taking from TNB has been reduced. Instead of taking 850 directly from TNB, now we generate our own energy, 605 kilowatt hour of energy that we use internally, and the rest, only the remaining 245 kilowatt hour we get from TNB. Okay, so now the new TNB bill, if you calculate, is only going to charge you for 245 kilowatt hour. So the first 200 kilowatt hour is going to be charged at a rate of 21.8 cents. And the next 45 kilowatt hour will be charged based on the rate of 33.4 cents. So when we multiply and add up, we get a total of 58 ringgit 60 cents. Okay, so because this is assumption, so there is slight difference in the value from the calculator and from our actual calculation. But it's okay because we just want to find the estimation. Okay, so now the minimum upfront cost is 6 kilowatt times 4,300 per kilowatt based on SEDA's assumption. So we get 25,800. The total savings just now, when we minus, if we go back, when we minus this value here, current monthly bill with the monthly bill after NEM, then this is the total savings, 306. So we get a simple payback of period of 7 years. So we go back. So 25,800 divide by 306 ringgit savings per month. So we get 84 months. After 84 months or 7 years, we are going to get back the 25,800 that we invested. And if we assume that the life cycle of our PV system is 25 years, means it's continue to operate for 25 years, that means the rest of the duration, as long as the PV system is working, we are going to get the savings, not actually going to get profit, but we are going to get actual savings in terms of the reduced amount of bill payment. So that is the essence of net energy metering and how it is calculated.